Don't you think we're done? Don't you think we're done? Make me feel alive. Take my hand and run, let me be the one. Let's just take the dive. Night's only begun. Don't you think we're done? I'll be your anything if you'll be the one to take me home. 'Cause right now everything makes me wanna leave this place and roam. Make me feel alive. Take my hand and run, let me be the one. Let's just take the dive.
Hello everyone and welcome back. This lecture is an introduction to exceptions, and in the upcoming lectures we'll dive deeper into this subject. In the previous lecture you've seen one way of reading files. We're going to use that as an example to continue explaining exceptions. So now I'm going to create a variable of type file as we did in the previous lecture, and I'm going to set it equal to new file. And to the constructor of file, I will pass a name of the file that I want to deal with. So let's say here example.txt. So the next step could be creating a new scanner object. And here to the constructor of scanner, I'm going to pass the file variable that we've just created. Now you can see two error icons, and we'll try fixing that with Ctrl-Shift-O by adding the import statements. So here are the import statements. But you can see that Java is still complaining, and if we hover over this error icon, you can see the type of the error that we've got. The first one says that read file is never closed, and we'll deal with that later. But for this lecture, the important thing is that we've got an unhandled exception. That's type file not found exception. And if we click over the error icon, you see two ways of dealing with this problem. The first one is adding throws declaration, and the other one is around with try and catch statement. So first we'll explain the add throws declaration. By clicking it, this throws file not found exception is added to the main method. So exceptions are just ordinary objects, except that they are derived from exception class and you use them in a particular way. So bear in mind that we have not defined this file example.txt anywhere. So this will for sure throw us an exception. And if we run this code, you will see the red text that appears in the console. So whenever you see red text in the console, you should scroll up to the first statement and you should read it from the top line down. So this is called a stack trace. And if we take a look to the first line, you can see exception in thread main. So this exception is coming from the main method, and it's java.io file not found exception type, so it's telling the type of the exception. Then you'll see further explanation of your specific exception. So here the system cannot find the file specified. So example.txt is not found because we have not defined it, so it actually doesn't exist. And if you read down at the bottom line, you can see application.java:11. So application.java is the class that we've created. And if we look down, the line 11 is where the exception is coming from. So if we read the line 11, it's where something went wrong. So in a nutshell, we think of this method as it encounters an error and reacts to that error by throwing out an object, and that object is an exception. And execution of my program has stopped to that point. The exception is thrown out of the main method. And that is possible because it has this throw file not found exception added to the header of my method. And when an exception is thrown out of the main method, you get a red text like this, which is called stack trace, and tells you what the problem is. Now let's take a look at another way of handling exceptions. So I'm gonna create a new package, and I'm gonna say example1, and I'm gonna put this class into this package. Then I'm gonna create another package. I'm gonna call it example2. I'm gonna get rid of the stack trace, and then here I'm gonna create another class that I'll call application as well, and I'm gonna add a public void main method to this class as well. Now I'm gonna go and copy this text right here, and I'm gonna paste it to our new class. And we're gonna take a look at the second option of handling exception, which is surround with try and catch. And this whole thing here is called try and catch block. And what this do is it says try to read this code, and if that throws an exception, go to the catch statement. And as a result, if this code throws an exception, we'll immediately go to the catch block. And the lines after scanner class won't be executed if this line throws an exception. So it will immediately jump to the catch block. But if it doesn't throw an exception, of course it will continue reading the code after the scanner class, line by line, as it usually does. And what we're doing here is that we're not throwing an exception out of main method. We're trying to catch it and handle it. And the catch block is where you put code which is executed after exception is caught. And the default here is e.print_stack_trace. And the exception is declared right here. So this kind of exception can be caught by this catch block. If we run this, it's gonna print the stack trace, which looks similar to what we just did. So it again tells you that the example.txt cannot be found. But if we go here and define this file, then the exception won't be thrown. If we say here example.txt, and if we try to run the code again, then we won't have an exception. So now the file is found, and an exception is only thrown if something goes wrong or if an error condition arises. And I'll just delete this again. And here you don't have to print the stack trace. By default it's here and it's very handy. However, you can put here another explanation. For example, a sysout statement. For example, let's do here a sysout statement. And I'm gonna say file not found. Plus, I'm gonna put here the variable file, and I'm gonna convert it into a string. So this should work fine. If I run this, it says file not found example.txt. So you can handle an exception any way you like. So remember that if we had another line in here, if we say hello there, this line will not be executed. It will jump straight out to the catch block. So again, it will be the same output as before we created this statement. However, after you've caught the exception, you can then continue and write code normally. So if we say here sysout, so if we run this, now this is going to be read and will be displayed in the console, as you can see here. And now you can continue with the program and write the rest of the code without any problem. And there is one last example that I want to show you in this lecture. And I'm going to create a new method. I'm going to get rid of the try and catch block. And I'm going to create a new method, public static void read. And I'm going to copy and paste these lines in our new method. And again, we're ending up with a code that tries to read a non-existent file. Now again, if we hover over the error icon, you have the same two options, add throws declaration and surround try and catch. If we surround this code with try and catch, the problem is going to end here, and we will just continue with the rest of the code. However, if you do a throws declaration, or if you add the throws file not found exception, and then if you try and call the method in the main method, let's say read, and let's get rid of our previous console. So now we have the declaration throws file not found exception in the read method. However, now we have an error in main which says unhandled exception, file not found exception. So again, I have to handle this exception somewhere, or I have to throw it out of main. So if we added here the try and catch file, it would have been handled within this method. But instead, we have thrown this exception out of read method. And now here, we either have to throw it out of main as well, or handle it in here. So I could add a throws declaration, and we'll have the same stack trace as before. Or I could try and handle it in here. So I'm going to delete the throws declaration, and I'm going to surround it with try and catch. Here again I can put a sysout statement. And again I can say file not found. However, it's always good when you have an error to have a specific message to your user. And if you intend your user to see this, the user should never see a stack trace, because a non-technical user will be horrified of a stack trace. So don't let your program produce a stack trace if it's intended to be used for other non-technical people. And in your message, at least add the name of the file that could not be found, because this message is too vague. So you should always make your message as specific as possible. So I'm gonna leave this lecture here because there's a lot of information to absorb. Next, you're gonna learn how to handle multiple exceptions. You're gonna see what types of exceptions are out there, like checked versus runtime exceptions. But before you dive into that kind of stuff, you should first understand what we've done until now. So make sure to practice on your own. The code will be in the resources section. And I'll see you in the next lectures.
Now I'm going to have to add a throws clause here. Hello and welcome back. In this tutorial, we are going to look at multiple exceptions and the way that we can handle them. I got a basic program set up in Eclipse. Let's create a new class here. I'm going to name this class Multiple Exceptions and click Finish. I'll create a method and make it public void. I am going to call it Start. Let's say that Start method throws some exception, or it could throw an exception, because it's very rare to use a method that automatically throws an exception unless it's some kind of none-implemented exception. Let's just say that we detected an error, and then we want to throw a new IO exception. Now I'm going to have to add a throws clause here. So let's just click the error and import IO exception, click it again, and then cut the throws declaration. So if you want to throw an exception, then you're going to have this throws and exception name there. But what if you want to throw another exception, because this exception might not get thrown in your code, because this specific thing might not go wrong? And it could be that something else goes wrong somewhere in your code. So maybe we've got through the input-output stage, and we didn't throw IO exception, but now another error occurs in the same block of code, and we want to throw a new parse exception. So we want to say, for example, error at line 10. Therefore, you might throw parse exception if you are passing something that don't follow the format you expected. I've got one unhandled exception. Let's click on the error and go to add throws exception. So now we've got a comma-separated list of exceptions. Keep in mind that this is not a list of exceptions that we're gonna throw, because you can only throw one exception at a time. And you might not throw any exception at all if the code is successful. Instead, this means that you could throw either one of these two exceptions if something goes wrong in the code. So these are two separated things that could go wrong, and for each one you can throw a specific exception. So basically you can add any number of possible exceptions to this comma-separated list of exceptions. Let's have a look now at how you'd actually handle them. I'll create an object here of type multiple exceptions. So multiple exceptions ME equals new multiple exceptions. Then I'm going to call ME start. Now I'm forced to handle those exceptions because ME start could throw either two exceptions, although it might not throw any if everything runs smoothly. So we've got a bunch of different options for handling that, and we've already seen the add throws declaration option, which will throw this out to main in this case. It throws it up to the next method in the hierarchy of method calls. Here we'll be throwing it directly out of the main method, which will produce some kind of stack trace if that error gets thrown. Now let's assume that you don't want to throw it out of main method, but instead you want to handle it. The first thing you can do is surround it with try and catch block. Although you've only got one try block, you can add multiple catch blocks, and depending on what error is thrown, you'll get into one of these blocks. So in this case, I'm actually throwing a parse exception. So I could say here, sysout, incorrect, format, or you can write here anything you think is appropriate. If we run this, then we get the error because we've thrown the exception, and this specific catch block has run rather than this one, because the catch block will match its argument here to the actual exception that's thrown. This catches IO exceptions, and this catches parse exceptions. And we've thrown a parse exception. So we've run this code here. Now, let's comment this out. Let's do me start again, and let's try another way of handling multiple exceptions. This way is called try multi-catch. So if I click the error here, I can say surround with try multi-catch. Now we've got a single catch block, but it lists two possible exceptions, and there is a vertical bar in the middle of them. You can add multiple exceptions there. So this can handle multiple exceptions in one catch block, and that's the try multi-catch. There is something else we could do to handle multiple exceptions. Let's say me start again. We have already seen the concept of polymorphism, which means that you can always pass a child class wherever a parent class is expected. Let's surround it with try and catch block. Now all exceptions classes derive from the parent class exception. If I change this to exception, it can now catch any kind of exception, because this is the parent class of all exception classes, and this would catch any child class. It can catch an IO exception, a parse exception, or any child class of exception, and that brings up an issue here. Supposing I've got a public void method here. Let's call this method example. Now let's say that this method can throw an IO exception, and for some reason, it could also throw a file not found exception, which is a child class of IO exception. I'll just add the import statement for that here. Now, if you think about how to handle that, I'll go to app here. Imagine we are running me example, which throws file not found exception, or it might throw IO exception. And imagine that I surround it with try and catch block. We have to have file not found exception first. And the reason for that is that if we had IO exception first here, then IO exception would catch file not found exception as well. What happens is Java goes down the catch blocks and says, does this match the exception? If yes, then we'll run this code. If it doesn't, let's look at the other catch block. Does this match the exception? If yes, then we'll run this block. And if we had IO exception here and file not found exception here, it would say, okay, file not found exception is an IO exception. It's a child class of it, and it would run this, and we would never reach this. For that reason, I think if we were to say here, file not found exception, and I were to put IO exception here, it won't even compile. So let's save this, and it will say here, unreachable catch block, and that's because we've handled them in the wrong order. So keep it in mind that if you got a child exception, you've got to handle it first before the parent, because otherwise the parent would catch it because of polymorphism. And that's it for this lecture. In the next one, we are going to look a little bit more into two different kinds of exceptions: runtime and checked exceptions. So
makes me wanna leave this place and roam. Make me feel alive. Take my hand and run, let me be the one. Let's just take the dive. Night's only begun, don't you think we're done? 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 Knew that it was true from the way you looked at me. At me. Don't know what to do, what to say to. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love.
turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Oh yeah. Doesn't wanna fall in love. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. 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 May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh yeah. Doesn't wanna fall in love. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay.
in Java. So
I'll be your anything if you be the one to take me home. 'Cause right now everything makes me wanna leave this place and roam. Make me feel alive. Take my hand around, let me be the one. Let's just take the dive. Night's only begun, don't you think we're done?
far we've looked at checked exceptions, and there are two kinds of exceptions in Java. Checked exceptions are the kind that you're forced to handle, that you have already seen in the previous lecture. But there are also exceptions that you don't have to handle, that you're not forced to handle, and these are called unchecked exceptions or runtime exceptions. An example of them would be division by 0. So let's say you've got an integer here. Let's say int value equals 11. And let's say value equals value divided by 0. This compiles so I'm not forced to handle an exception here. However, it throws an exception. So if I run this, it's gonna give me an arithmetic exception, which is a child class of runtime exception. And runtime exception, like all exceptions, is a child class of Java lang exception. So runtime exceptions and any of its child classes don't force you to handle them, which is why we don't have to put a try-catch in here. And runtime exceptions are things that are really serious. They are fundamental errors in your program. So if you've got a runtime exception, it's something that your program is unlikely to be able to recover from. And for that reason, it doesn't even force you to catch it. If your program is throwing runtime exceptions, then there's something really seriously wrong with it, which you should have addressed. An example would be a null pointer exception. I will say string empty without saying empty equals new string or empty equals some kind of text. Now I will call a method of string like empty.length. Let's put here sysout empty.length. Now this isn't going to compile. It is going to say that text is not initialized. But if I set empty equal to null now, the compiler says, okay, you have initialized empty with something. But I still can't call a method on it, because all I've got here is a reference that points to nowhere. I don't have an object that contains actual code to implement this length method. So if I run this, I'll get a null pointer exception. There is one more example I'd like to show here, and that is array out of bounds exception. Let's create an array of strings, and I'll call this array numbers. I'll initialize this to 1, 2, and 3. Now, there are 3 strings in this array, and we start numbering the different values with index 0. So if I say sysout numbers, and I try to access item number 3, so this is item 0, this is item 1, and this is item 2. So if I try to access numbers 3, I get this array index out of bounds exception, which again is a runtime exception. I'm not forced to handle it, but nevertheless it occurs. Just like null pointer exception and arithmetic exception, This is pointing to a really fundamental problem in my program, which my program is not able to recover from. Therefore, you should always fix your code when you have runtime exceptions. You should not try to catch them even thought you could, because they do generally point to fundamental flaws in your program which you really need to fix. That is how we came to the end of this lecture. You can find this code in the resources section. And until next time, keep practicing. Hello everyone and welcome back. In this lecture, we are gonna talk about the equals method in Java. Let's create a class here. I'm gonna call this class laptop. Now I'll give laptop a couple of fields. So I'm gonna say private int ID and private string brand. And I'll give it a constructor. Right-click. Go to source. Generate constructor using fields. I'll check the fields that I want to include as parameters of the constructor, and then click OK. Let's get rid of the super, which is actually unnecessary. I'll also create a toString method. So I'm going to right-click, go to source, generate toString. Check the fields that I want to include, and click OK. So now I'm gonna create two laptop objects, and I'm gonna talk about how to compare those two laptop objects. So let's say laptop1 equals new laptop. Let's give it an ID of 250. Let's say the brand is HP. And the other object, laptop2, equals new laptop. Let's give it an ID of 90 and a Dell brand. Are these two laptops equal or not? If we want to know whether they are equal or not, we could do this. We could say sysout control space. Let's say laptop1 equals laptop2. So we're comparing them with equals. And if I run this, it's gonna output false because they are clearly different objects. Now what equals does is it tells you whether two references to objects are pointing at the same object or not. Or with primitive types, it tells you if those primitive types have the same value. But with non-primitive types like references to objects, tells you if they're pointing at the same object or not. So if I point laptop2 at laptop1, then it's going to say that they are equal, so it outputs true. Thus, when two objects are equaled has nothing to do with whether they are literally the same object or not. For example, if a laptop object has the same ID and brand, we might argue that they should be considered equal. And that's what ID.equals method is for. So let's change them so they are both equal in terms of meaning. So we've given them the same ID and the same brand. If I run this, equals still gives us false because these are two different objects. They contain the same information and we feel that they are the same, but in terms of memory, they are kind of physically two different objects. So how can we compare them in terms of meaning? And what we should do is, we use .equals, which is a method that all objects inherit from the object superclass, and we can override this method to provide our own interpretation of it. If I just run this, it's gonna still say false, because we haven't told .equals how to compare these two objects, and we can do that by overriding .equals and implementing it ourselves. The easiest way to do that is to right-click in your class, go to Source, then generate hashcode and equals, and we'll talk about hashcode in a little bit. And then tick the fields that you want to compare. So if you think that two laptop objects with the same brand are equal regardless of ID, then just tick brand. Or if you think that having the same ID means they are equal regardless of brand, then just tick ID. Well, hopefully you got the idea that you need to tick fields that are important in comparing the object. If you think that in this case, two objects must have the same ID and the same brand in order to be considered equal, then you tick both. If you have a lot of fields, you only tick the ones that are important when you compare the objects. So I'll tick both here, and I'll click OK, and it generates this .equals method for me. And all this is doing is it's trying to compare the two objects efficiently. So it does a load of tests, but it is actually just saying, is this object equal to this object? And that's all it's doing. So now if I run this, .equals will output true because our objects are equal. And if I change brand, for example, or ID, then they're gonna be false because I ticked both ID and brand. So they must have the same ID and the same brand to be considered equal. So that's .equals method. However, with primitives you can just use equals equals to compare them. Let's do an integer value. Let's say first number equals 8. And integer, second number also equals 8. So let's say first number equals second number. Let's run this, and it does work, it outputs true. So you have to be a bit careful here. Keep in mind, equals equals is only checking if two references are pointing literally at the same object. And the safe way is to use .equals, which will tell you if they're equal in terms of value or not. Now the tricky part is, when it comes to strings, a common beginner's mistake is to compare two strings with equals equals. Let's create two strings here. So string A equals yes, and string B equals yes as well. And let's try that. Let's say this out. A equals equals B. Now what do you think? It's gonna be equal or not? If you run this, they are pointing at the same string. And that's because Java points these two references at the exact same object. So keep it in mind that you should not compare non-primitives with equals equals. Only use equals equals to check if two references point at the same object. And the same with strings. Always use .equals to compare strings, because this will play you false. Equals equals is only checking if these references are literally pointing at the same object or not. And to show you what I mean, let's add some more characters to this. And then let's do substring on it. I'll say .substring, start index 0 and index third character. And then do a sysout. Now let's output string B and run this. And what we find is that B is equal to yes, because we added more characters to the string, but then we only took the first 3 characters of that, so it is yes again. and string B is equal to yes. Therefore, the equals equals is not giving correct result. While it's actually doing what it should do, it's telling us that these references point to different objects in memory. And for that reason, what you should do is always use dot equals with strings. Thus, you cannot rely on equals equals because you really need to compare strings in terms of the data they contain. And for that, you need dot equals. So equals equals is to check if you've got literally the same object, whilst dot equals is for comparing in terms of meaning, which is what you almost always want with strings. And as we've seen, you can implement your own equals method just by getting your IDE to do it for you. I just want to very quickly mention this hash code method that was also generated for us. If you take an object that doesn't have a toString method, you will see this output. Let's try this and say sysout control space new object. I'll run that and you will see this ID here. If this had a toString method that actually would implement it to return something other than the default, then we wouldn't see this. But by default, the parent object outputs this stuff. And this is the class of the object, including the package that it's in. This is just an @sign, and this looks like a memory address, but it's not. It's what's called a hash code. And hash codes are just unique ID that each object has. And it's actually literally the value returned by this hash code method here. So that's it for equals method, and that's the end of this lecture. Until next time, keep practicing.
lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Oh, yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Oh yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not see eye to eye, but we can be chill for just this moment. So turn out the lights and let's make a deal to just enjoy it. I'm not thinking about forever. I won't care if we don't end up together. Let's get high tonight, 'cause fuck how we feel, yeah. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall. Doesn't wanna fall in love. Oh yeah. Doesn't wanna fall in love. Yeah. Doesn't wanna fall in love. We've lost track of time, don't know how to feel, but I'm not sorry. I'm lost in your eyes, are you even real? But don't you worry, I'm not looking for the one. No, I just wanna have some fun. So let's get drunk tonight, 'cause fuck how we feel. But for now, I won't give it all away, 'cause I don't think I'll stay. No, I can't be the only one who doesn't wanna fall in love. Doesn't wanna fall. Doesn't wanna fall in love. Doesn't wanna feel. Doesn't wanna fall in love. May not
I'll be your anything if you be the one to take me home. 'Cause right now everything makes me wanna leave this place and roam. Make me feel alive. Take my hand around, let me be the one. Let's just take the dive. Nights only begun, don't you think we're done?
In this lecture, we are going to look at abstract classes in Java. You can use abstract classes when you want to create class hierarchies. And the base class is not going to be able to do anything in itself. Let's take an example. Let's say we'll have a base class called vehicle for our class hierarchy. So I'll create a vehicle class, and I might have a bunch of different subclasses. For example, car is a vehicle. So I will say public class car extends vehicle. And a truck is a vehicle. So let's create a new class. And let's say class truck extends vehicle. Now, both car and truck may have some functionality in common. For example, it may be that both the car and truck in my program have engines. So I can add that common functionality to the parent class, which makes complete sense. Thus, I will say private string engine. And I will right-click, go to source, and generate getters and setters for engine. And then every vehicle that extends this abstract class has an engine. Now I can do things like car1 equals new car. Then car1 dot set engine to hybrid. The same is for truck. Truck1 equals new truck. Then truck dot set engine to electric, or whatever. You get the idea. There is one thing you must remember when it comes to abstract classes. You can never instantiate an abstract class. For example, you cannot say, vehicle1 equals new vehicle. At the end of the day, why would you create a vehicle object? When in real life there is no such thing as vehicle. There only exist specific vehicles, such as car, truck, motorcycle, or something like that. Therefore, vehicle is completely abstract. Keep that in mind. That being said, let's move on to abstract methods. Let's say I now want to force 3 vehicles to have a method called drive. Because I might think, well, every vehicle that I'm going to have in my program has to have a drive method to keep moving somehow, whether it's a car, a truck, or whatever it is. If you want to force all your child classes to implement this method, you have to make it abstract. However, the implementation of this method is going to be completely different for every particular kind of vehicle. I can say public, abstract void, drive, and then instead of having brackets here, I will just put semicolons. So it is exactly like the declaration of a method in an interface. I got an error here because I have to add drive method in car class. So if I click the error, I can go to add unimplemented methods. And the same goes for truck class. They can have whatever implementation would make sense for this particular class. So this is pretty similar to using an interface. And another thing to bear in mind is that a class can implement many interfaces, but it can only have one parent class. So it can only have one abstract class in the hierarchy. You're only going to be able to extend one abstract class, but you can implement as many interfaces as you like. So that's the end of this lecture. You can find this code in Resources section, and until next time, keep practicing.
be your